So reflections are just another way to manipulate shapes or points in the coordinate plane, right? What can we do to the shape? We can slide it around, which is a transformation. We can spin it, which is a rotation. Or a reflection is just like it sounds. You're literally just going to flip this over a certain line, right? And so there's actually infinite number of reflections you can do. You can reflect it across the x-axis, and it's going to show up down here, right? You could reflect it across the y-axis, and it would show up over here. You could also reflect it across any line you invented. You could put a line here and then reflect it over that line. So there's an infinite number of reflections. And that being said, for this lesson, we're just going to stick to 3. We're going to reflect a shape across the y-axis. We can reflect it across the x-axis, and also we're going to reflect it across this, what's called the y equals x line. And let me just draw that quickly. The y equals x line is essentially a line that goes right through the origin with the slope of 1 and the y-intercept of 0, just like it sounds. Y equals x. Obviously, the slope is 1 because there's nothing in front of the x, and the y-intercept would have to be 0 because there's nothing after it. So y-axis, x-axis, and this kind of diagonal line, the y equals x line that goes right through the origin. And so let's kind of take a look what happens to the points when we do this. And when you do a reflection, you really would do, in this case for the shape, 1, 2, 3, 4, 5, 6, 7 points. Do 1 point at a time, find the new value, and then you can connect your shape to look like this little house, right? But in order to kind of teach you this, let's just look at 1 point, the kind of the bottom corner here. And now if I were to do a reflection across the y-x or the y equals x line, something kind of a pattern emerges, right? And so look at this shape here. If we flip this over here, it would look something like this. And you can tell by looking at it that, so now this point, if I had flipped it over onto its back, is now here, right? And you can kind of tell just by glancing that this looks like it's the same direction this way that it is this way. And that's exactly right. You're going to take your x value that used to be positive 4, and all you're going to do is change it to a negative value, negative 4. The same direction it used to go right, it now goes left. And doesn't it look like it went up the same direction? So if this was up 1 before, it doesn't look like it's still up 1. That is exactly the case, right? So all you did when you flipped over the y-axis was you changed your x to a negative and you kept your y the same. And I'll write these down later so you can just flat out cheat from your cheat sheet. But it's really that easy of a concept. And now let's talk about what happens if we flip this over the x-axis, right? It would look something like this. So having flipped this down, you see that there's sort of, again, a pattern here. It looks like if this was over 4 and up 1, isn't this still over 4? So the x is still a positive value. It's still the same value that you started with, right? This was over 4. This is definitely over 4. But what's different is if this is over 4 and up 1, it appears as though this is over 4 and down 1. And that's exactly it. When you flip across the x-axis, you're going to keep your x value the same, and your y is going to become negative. Now, what's much harder to draw is and I'll attempt it, but essentially now we're going to rotate this across the y equals x line, and it's harder to sketch. But what's interesting is the pattern is very cool and predictable. So it might look something like this. Okay, we agreed you weren't going to make fun of me, right? So, but the pattern here is if I were to flip this across this y equals x line, the pattern is super interesting. What happens is if this was over 4 and up 1, this is going to be over 1 and up 4, right? So it's literally all you do for flipping across the y equals x line is you change your x and y values. So if this used to be 4, 1, flipping it across the y-x is now 1, 4. And we would do that for every single point, one at a time, to find our new points. So here's kind of the text version of the cheat sheet that I just gave you. So reflecting across your x-axis, anytime you had an x, comma, y, you will now have an x comma negative y. So the example, here's a perfect example. You could have, starting with, 3, 5, you would just flat out get 3, negative 5. It's that easy, all right? What about the y-axis? Remember the y-axis rule was if you started with x, y, then you would end up with negative x comma y. So, let's do another example. So if this was 2, 7, now this would be negative 2, 7. It's really just that easy. Okay, what about the y equals x line? Well, this one, if you add x comma y, you just end up with y comma x. So let's say, a random point. Let's say, okay, I have a point that's 6, 2. Now my new point after reflecting across the y equals x would just be 2, 6. And again, for a shape, obviously you're going to have more things to deal with than just 1 point. But all you do is you do each point of that shape at a time, and you'll end up with your new reflected shape, either across the x-axis, y-axis, or y equals x line. That's it. Hopefully you guys understood that, and hopefully you guys aced the section. Good luck.